Okay, hi guys. So in the previous lecture, we were seeing the tips for drawing the structure of inorganic compounds. So we'll be continuing on the same. So first, let's see that the basicity of some acids which does not depend on the number of H atoms. Basicity of acids which does not depend on upon the number of H atoms. Okay. So for example, if we have acids like S3PO4, which is phosphorus acid, S3PO3 rather, this is phosphorus acid. So the basicity of this acid is 2. So it seems like the basicity of the acid is 3. Basicity is nothing but the power of an acid to release the H plus into the aqueous solution. So in this case, we can theoretically see that it has 3 hydrogen atoms, so it can release 3 H plus in the aqueous solution. But as a matter of fact, the basicity is just 2, which means that it can release only 2 hydrogen atoms in its aqueous solution. If we talk about S3PO2, which is phosphorus acid, hypophosphorus acid, so the basicity of this acid is 1. And if we talk about H4P2O5, which is pyrophosphorus acid, so the basicity of this acid is again 2. Okay, next let us see next concept, which is parent oxy acid. So under parent oxy acid, we can either have is form of parent oxy acid. We have two forms. First is form, rather ic form, we can say that ic form of parent oxy acid, and second we have us form of parent oxy acid. As form of parent oxy acid. So in the ic form, the central atom is carrying higher oxidation state. Central atom is carrying higher oxidation state. And in the us form, the central atom is carrying lower oxidation state. Lower oxidation state. Okay, so the corresponding salt is 8 suffix, has 8 suffix. The corresponding salt, rather, salt has 8 suffix. And here the corresponding salt has 8 suffix. Salt has 8 suffix. Okay, so with this we see the corresponding what is a parent oxy acid. Next notice that as far as possible there should be symmetry in the structure of a compound. So we can write that as far as possible there should be symmetry in the structure of compound. Whenever you draw any structure of inorganic compound, there should be symmetry in the structure of compound. Okay. Next, let us see the prefixes of oxy acid. Okay. So first we have meta acid, or rather meta prefix. So meta prefix is provided to that oxy acid which is obtained by removal of one water molecule from one parent of oxy acid. So we can write that suppose this is our parent oxy acid. We are taking one molecule of the same, okay, and we are removing water molecule from this to get meta form of oxy acid. To get meta form of oxy acid, provided it should be, rather it should also be an oxy acid. Provided it should also be an oxy acid. Okay, so examples of the same is, suppose we have something like this, that we have n moles of H3PO4 or n molecules of H3PO4, which is phosphorus acid, and we remove NH2 molecules from the same, so we get HPO3 whole n. Okay, so this is metaphosphoric acid. Phosphoric acid rather. So first of all, I wrote the name wrong here. This is phosphoric acid. H3PO3 is a phosphorus acid. Okay, so this is metaphosphoric acid. Just add meta prefix to the parent oxy acid's name. We have n molecules of, this time we have phosphorus acid. We remove NH2O from the same, and we get HPO2N. Okay, so this is meta phosphorus acid. Okay, next we have NH3BO3, which is boric acid. We remove NH2O from it, so we get HBO2N, which is again metaboric acid. Okay, next let us see what happens when we have n moles of or n molecules of H2SO4, which is nothing but sulfuric acid, and we remove NH2O from the same, so we get SO3 whole n. But this is not a metaform. Why is this not a metaform? Because for the metaform to exist, the corresponding metaform should also be an oxy acid. In this case, it is not an oxy acid. Hence, metaform of sulfuric acid does not exist. Similarly, if we have H2SO3, which is sulfurous acid, and again we remove NH2O from the same, so we get SO2 whole n. Again, it is not an oxy acid, hence metaform of sulfurous acid also does not exist. So I used the generic variable n here, so n can be ranging from 3, 4, 5 and so on, as these meta acids does not exist in monomer and dimer form, as these meta acids does not exist in monomer and dimer form. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on meta acids, and then rather meta prefix, and then more prefixes of oxy acids. So till then, good luck and goodbye.